In this video we'll be looking at turning decimal fractions into binary numbers. If you haven't already looked at the video of turning decimal numbers into binary numbers, I do recommend watching that first so you've got a good jumping off point for how this one works. There are two ways to turn a fraction into binary, and we're going to look at the less scalable way first. The way we're going to look at doesn't really work for very complex fractions if you're working it out yourself, but it will help you understand why we do things the way we do. So you're going to be, first of all, very familiar with our standard binary table. Of course, if you've seen the video of converting decimal into binary, you'll know exactly what this table is and how it works. When we're turning fractions into binary, we go the other way. So we go 1 over 2, 1 over 4, 1 over 8, 1 over 16, and 1 over 32. The essential same numbers as we go to the left, except we're going to the right. If we were to turn this into decimal numbers as opposed to fraction notation, it would look a little something like this. 0.5, 0.25, 0.125, 0.0625. So this is this, this, and finally 1 over 32 as a decimal fraction looks like 0.03125. I had to kind of remember for myself there. As you can see, the smaller and smaller our fractions get, the more complex these numbers get. But let's just take a quick look at a very simple fraction such as 0.75, otherwise known as 3/4. If we want to use our table here to denote a fraction the way we have previously, we'll start by filling all of these up with 0, because we know that none of these will fit, because 0 in binary is 0. Next we will look at this 0.5, and 0.5 does fit into 0.75, so we're going to leave a 1 here, and subtract that from our value, as we've been doing before, to get 0.25. Now we have 0.25 here, subtracting 0.25 from 0.25 equals 0, so we know we're done and we can continue as normal. Through this method we know that 0.11 is 0.75 in binary. Let's look at the other method for doing this. The other method doesn't use our binary table as before. Instead we're going to write our number out here. 0.75. The first step to figuring out this number in binary is to multiply it by 2 and then take a look at the result. 0.75 times 2 is 1.5. If our leftmost number here is a 1, we take that 1 and we write it down. We then subtract that 1 to leave the value of 0.5. Now we're going to take 0.5 and we're going to times that by 2. That will give us 1.0. Again, our leftmost number is 1, so we're going to take that 1 down, subtract 1 from this value, and that will leave us with 0. And of course, as we know from figuring binary out, if we're left with 0, we are done. Which means that 0.75, if we look down these numbers here, will be 0.11. And then 0 recurring. Let's try it with a different number. Next we're going to use the number 0.625. Try and follow along with me on this one and see if you can figure it out for yourself. First of all, we're going to multiply it by 2. 0.625 multiplied by 2 is 1.25. Our leftmost number here is a 1. So we're going to take that 1, remove it from here to leave 0.25. Our next number will be 0.25 multiplied by 2, as before. This will give us 0.5. Our leftmost number is a 0, so we're going to leave 0 here and take 0.5 down to the next row. 0.5 times 2 is 1. So we're going to take that 1 take away the 1 here to make it 0, and of course we know we're left with 0, so that means we are finished. Going from top to bottom, we have the numbers 1, 0, 1. 0.625 in binary is 0.101. This method doesn't always work so simply. Some numbers have a certain special property which can cause a problem in our method. Let's take a look at one such number. We're going to take a look at the number 0.1. 0.1 gives us an interesting property when working out fractions in binary, in that binary can't actually display the number 0.1, it can instead display the closest possible number that its number of bits allows it to display. We'll explain why in just a moment, but first let's try and work this out. Follow along with me and see if you can find what's happening. 0.1 times 2 is 0.2. We're going to take this 0, and we're now going to take 0.2, and we're going to multiply it by 2. This gives us 0.4. We're going to take this 0, and now take 0.4, and multiply it by 2. This gives us 0.8. We're going to take this 0, and we're going to multiply 0.8 times 2. This gives us 1.6. We're going to take this 1, subtract it from the value to get 0.6, and now we're going to take 0.6 and multiply it by 2. That gives us 1.2. We're going to take this 1, subtracting it from the value to give us 0.2, and we're going to multiply 0.2 by 2. This will give us 0.4. We're going to take this 0, and then we're going to multiply 0.4 by 2. That will give us 0.8, so we're going to take this 0, and multiply 0.8 by 2. That will give us 1.6. We're going to take this 1, subtract it from the value to give us 0.6, and then multiply 0.6 by 2. That will give us 1.2. We're going to take this 1, leaving us with 0.2. We're going to take that 0.2, multiply it by 2 to give us 0.4. We're going to take that 0 and multiply 0.4 by 2. That's going to give us 0.8. We're going to take this 0 and multiply 0.8 by 2. That's going to give us 1.6. We're going to take this 1, leaving us with 0.6, and we're going to multiply it by 2. That will give us 1.2. We're going to take this 1, leaving us with 0.2. And can you see the pattern that we've got emerging here? We are stuck in a constant loop of 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1. And this loop will continue ad infinitum. Binary cannot express the number 0.1 as a fraction. The closest it will represent is 0.099999 recurring, depending on how many bits you have. So if we were to want to say 0.1 in decimal as binary, it would be 0. And we're going to take our numbers going down here. 0, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, and these numbers would repeat. So 0.1 in decimal is 0.0001100110011 repeating in binary. Let's take a look at one more number with this property. Let's take a look at the number 0.3, and we'll see a very similar property with 0.3. Let's first multiply it by 2, and that gives us 0.6. We're going to take our 0, and immediately, if you're paying attention, you'll see a problem in the first step here. 0.6 times 2 is 1.2. Take the 1, leaving 0.2. 0.2 times 2 equals 4, 0.4. 0.4 times 2 equals 0.8. 0.8 times 2 equals 1.6. And now we're going to begin the loop that we just discovered in our previous version of this method. And our number will go like so, infinitely. So 0.3 in decimal equals 0. We're going to follow our numbers down. 0, 1, 0, 0, 1, 1, 0, 0, 1, 1. Repeated in binary. Hopefully that has helped you learning how to turn decimal fractions into binary numbers. Of course, if I can help any further, please let me know.